All right, everyone, here we are with Fusion 360. Um, by now, we've went over some of the Fusion 360 interfaces. You've done a few things as far as understand the hierarchy of the tools. Now, let's get to the game over, under, and the wings. So, wings, bumpers, flats, outriggers, tri-ball pushers, extendable bumper, so on and so forth. So, I created a folder, wings, bumpers, flats, over, under, and what we did previously is we worked with a team with some R&D for the flywheel. So we also have a disc that holds nuts and bolts that acts as a flywheel. So first thing, what we're going to do is everyone's pretty much figured out about an 8-inch by 2.5-inch flap works really well. So we're going to use the spacing that's on all of the C channel, which I'll show you as we go. So what I'm going to do is I'm going to just create, it's not an assembly, so I'm going to go ahead and create this, and I'm going to create a sketch. I'm going to use 2-point rectangle, and I'm going to key in 8, and then I'm going to do 2.5. Okay, so we know the holes that are on the C channel are 0.25 and 0.25 from the edges. So if we go ahead and put a point out here, we can then hit D for dimension, and we can start dimensioning it out 0.25. And then what we'll do, we'll lock this one in place right here by dimensioning 0.25. So we have a point. Now the next thing we're going to do is come back up into our sketch palette. We're going to grab a rectangle, but a different one. So this one is a center. We're using an 832 bolt. Now the Vex C channel, they have tolerance in them. So they actually set it at 0.182, which is 182 thou, 0.182, and there's your rectangle. Okay, so see how it went ahead and put all the constraints? We constrained it, that point, to quarter inch off, and then now you have the parallels, you have the congruencies. What we're going to do now is turn it into a like a solid model. So we can hit E on the keyboard, or you can go over here. So I like to start using the hotkeys. We're going to extrude it 060, right? So 60 thou in the upward, downward direction right now does not matter. So I'm going to hit OK. So just so you can see, there's the origin. You see your XYZ still, so you can turn these on and off. There is a body here, and there are sketches. Okay, this becomes important. So what we want to do is start patterning this piece. So we can use like a hole feature to create the holes, but we're actually doing square holes, right? So there's a little bit of tolerance, right? Because we have tolerance stack. Means that if this little thing's off and this little thing's off, you actually need that tolerance for some fitment. So what we're going to do, we're going to create rectangular pattern, and right there, if we were to use the hole tool, it would have been a feature, but we're going to grab these faces. So shift middle scroll wheel, and then I'm going to show you a through select. So I'm going to left click and hold it. That way you understand how to do this, because I'm actually going through that face and selecting something. Okay, so I'm going to select this axis. So I'm going to throw it 2 directions. So I'm going to go in this direction, and then I'm going to go in this direction. And so when I do this, you're going to see that it's actually giving me a distance of 090. And let's see, I think from center to center, if we use extent, we should probably do spacing, center to center. So that's saying a 1/2 inch, or that's 450 thou, and it's 3 by 3. Uh, let's set it at that 50 thou, or that 500 thou. That way it's the 1/2 inch. But let's just throw this, let's say about 16 or so. So if we throw it 16, we know that it went all the way to this edge, and we could actually measure the distance from here to here. That was just a really good guess. So if that's 16, and we do the same thing over here, that means we can go to a spacing of zero point 0.5, and then we can get, say, 6. Now, 6, you've extended the faces off of the edge, so we can go back and say 5, and that will give us enough holes that this can be like a proto board. Then you can draw with the Expo, and then you can go back and modify this sketch as needed. Now, the cool thing is, because we use this pattern tool, if we go back and edit this sketch, it will automatically update all of these holes. And you can see that we still have that first reference, but we can update all these at one time. So that's really great. Now, the next tool we're going to use, we're going to put some fillets on these. So once again, this is the slow way to do it, but it is the way you start out, by just panning, rotating, orbiting around your part, finding these edges, and we're going to set a pretty good little fillet on these. And let's say 0.02. Ooh, that's really small. So let's go 0.2. Oh, that looks pretty. So that gives you a nice round edge. We still have enough material left in this corner, so this won't snap out. So that looks pretty good. So we're going to set that there. The last thing that we would need to do is to grab the DXF off of here. Now we have a single sketch, but that sketch only includes this hole. So what we do is we use a projection. So if we go create, sketch, and notice that I'm on the surface of this, okay, you can see that it went ahead and anyway, zoomed in there. So I'm going to go to project include. Notice it has a P right here. So if you hit P on the keyboard, it's going to pull up a projection. You can go projection length. I can hit OK. And now I have the second sketch that's activated. See where the purple reference points are? So that one will actually name wing DXF. Wing DXF. And then I'll go save as DXF. Wing proto plate over under. So then you can get fitment, come back to your sketches, and work really well. So I save that. Now I can go to Lightburn and upload and start running my parts on the laser. So that's how you could do the wing. Make sure that you do save it. Wing bumper outrigger plate. So you don't have to get that crazy on your naming schemes, but it's one component. You have your DXF, finish that sketch, and now we have a part that we can start putting on our robot. What some of the teams have done, they've actually put these at a slight angle, okay? And what that allowed them to do is add a little upward force onto the tri-ball to push it a little bit easier. So you'll come up with things. Remember, you can get in here, you can edit the sketch, and while you edit the sketch, then you can, you know, add the 3D model like from your sketch. So you can just modify it from here, but that's how you can create that proto plate without having a part to do projections off of. So anyway, use it as you will. You can accept or reject it, but have a great time CADing.